Turn to page 178. 178. 178. All right, here's our learning target. Use slope to identify and distinguish between parallel and perpendicular lines. All right, we've defined both parallel lines and perpendicular lines. Parallel lines are coplanar lines that do not intersect. Perpendicular lines are lines that intersect to form right angles. So we're going to learn to use slope to tell when we have parallel lines, to tell when we have perpendicular lines, or to tell if the lines we're talking about are neither parallel nor perpendicular. Little review here. The definition of the slope of a line is this formula. We call it the slope formula. It's the definition of the slope of a line. Okay? We'll say things like rise over run, but the way you find it is with this formula. Lowercase m stands for slope. I don't know why m stands for slope. I guess because slope starts with an, no, that's not why. All right, so it's y2 minus y1 over x2 minus x1. And those variables with the subscripts mean the same thing they did back when we did distance formula and midpoint formula. Y2 is the y-coordinate of the second point, y1 is the y-coordinate of the first, and so forth. Now, the order that you put these in matters. It still doesn't matter which point you choose to be the first point and which point you choose to be the second point. But since there's a minus sign between them, if you do y2 minus y1 in the top, but in the bottom you do x1 minus x2, you've reversed it, you're not going to get the correct slope. Okay? So the order does matter. Pick a point to be the first point, pick a point to be the second point, and stick with it. So let's do an example. Let's see, where am I getting this one from? So this would be from page 190. Find the slope of each line. Now, to find the slope of the line, we need to know the coordinates of 2 points. Actually, we can also tell from the graph sometimes if it hits the intersections of the grids just right. But we're also going to kind of freehand sketch our own graphs. So let's try to go by actually identifying coordinates of points, not just looking at the graph. What are the coordinates of point K? What's the x-coordinate?
3.
X-coordinate's 3, y-coordinate?
2.
What kind of 2? -2. All right, for J, what's the x-coordinate? -2, and the y-coordinate? 3. So it doesn't matter which one we call the first point, which one we call the second point. I'll call this one the first one, this one the second one. So we find the slope. M equals y2, so y2, that's the y-coordinate of the second point, -2, minus y1, the y-coordinate of the first point is 3. In the denominator, x2, that'll be 3, minus x1. That'll be -2. What's -2 minus 3? -5. What's 3 minus -2? +5. And what's -5 divided by +5? So the slope is -1. So do you think you can use the slope formula? All right. Number 2. What are the coordinates of T? -2, 2. What are the coordinates of U? -2, -2. Anybody know what we're going to get before we actually do this? We're going to get undefined, because that's a vertical line, and something you probably learned last year is that the slope of a vertical line is undefined. And I'll show you why it is. So M equals. All right, we'll just go with that one first, that one second. So y2 minus y1 over x2 minus x1. So we get -4 for our numerator, but we get 0 for our denominator. And we can't divide by 0, can we? It's undefined. Right? There is no definition of dividing by 0. In math, if things aren't defined, then you can't do it. Okay? So there is no definition of how to divide by 0, so we say that the slope is undefined. You need to remember that the slope of a vertical line is undefined. And anytime you have a slope that's undefined, it must be because the line is a vertical line. Okay? They go hand in hand. If you have a vertical line, slope's undefined. If the slope's undefined, you have to have a vertical line. Okay? All right, number 3. What are the coordinates of A? 1, looks like 1.5. We'll say it is. All right. B, what do you think those coordinates are? Negative 1.5, negative 1.5. Now, could we be off a little bit? Could it be 1.52? Yeah. Okay, but we'll go with it. So slope equals y2. I'll let B be the second point. Y2 be negative 1.5 minus y1, 1.5 over x2, negative 1.5 minus x1, 1. So what's negative 1.5 minus 1.5? Negative 3. And then negative 1.5 minus 1. Negative 2.5. Now I know that negative divided by negative is positive. And I don't want to leave, if we get fractions a lot for slopes, but I don't want to leave it with a decimal in my fraction. So 3 divided by 2.5. I didn't really want to get a decimal as a slope either, but there we go, 1.2. Now, you know how sometimes you use slope to have, if you know one point and you know the slope, you can count over whatever the denominator is and then up or down whatever the numerator is to find another point on the line. Is that a very useful form to do that? It's not. So I'd rather have had a fraction. I don't remember how to work with fractions. I wonder if my calculator can help me. Watch this. This is cool. 3 divided by 2.5. Then I hit the math button, and I choose number 1 because that says fraction. Ooh. Everybody. Ooh. It changes it to a reduced fraction. It's still improper, but it changes it to a reduced fraction for you. Isn't that cool? Now, what would I accept as correct on a quiz? Either one of them. 1.2, 6/5, whatever. Okay? 6/5 is more useful as a slope. It's more descriptive, isn't it? From any point, you go 5 to the right, 6 up, and you end up back on the line. Okay? All right. Now, I hope you remember these things from algebra. Whenever the slope is positive, the line slants up to the right. Whenever the slope is negative, the line slants down to the right. If the slope is 0, you have a horizontal line. And if the slope is undefined, you have a vertical line. So if the line slants up to the right, its slope is positive. If it slants down to the right, its slope is negative. If it's a horizontal line, its slope is 0. If it's a vertical line, its slope is undefined. All right? Does all that seem familiar to you from last year? All right, good, good. And if it's not, now you need to remember it, okay? All right, now back to our learning target. We've reviewed slope. Back to our learning target. We're going to use slope to identify and distinguish between parallel and perpendicular lines. All right, so here's what we have. The slopes of parallel lines are equal. Parallel lines have the same slope. Write that down. The slopes of parallel lines are equal. Parallel lines have the same slope. So, if I tell you that two lines are parallel, you should conclude that means their slopes are equal. If I tell you that the slopes of two lines are equal, you should conclude that means they're parallel. Then the next sentence, the slopes of perpendicular lines are opposite reciprocals. Now, the phrase or the term opposite reciprocals may be new to you. In math, opposites are numbers with opposite signs. 3 and negative 3 are opposites. 5 and negative 5 are opposites. 2/3 and negative 2/3 are opposites. So when we say they're opposite somethings, it means one of them's positive, one of them's negative. A reciprocal of a number used to be called the inverse. All right? You just flip it over. The reciprocal of 3/4 is 4/3. The reciprocal of 7/5 is 5/7. The reciprocal of 8, think about it, is 1/8. Okay? So the slopes of perpendicular lines are opposite reciprocals. So 2/3 and negative 3/2 would be a pair of opposite reciprocals. They have opposite signs and they're reciprocals of each other. Okay? So that's the slopes of perpendicular lines. If I tell you that you have a pair of perpendicular lines, you conclude their slopes are opposite reciprocals. If I tell you that the slopes of two lines are opposite reciprocals, you conclude the lines are perpendicular. Okay? Now, vertical lines mess everything up. Okay? Those two sentences that I have highlighted are true for non-vertical lines. So now let's talk about vertical lines. Well, vertical lines are parallel to other vertical lines. But you see how come that I have to point that out? Because this sentence really doesn't work for vertical lines, does it? Because what's the slope of a vertical line? Undefined. And it's not mathematically correct to say that undefined equals undefined. When you take calculus, you'll understand why. Okay? But it's not. So we have to say, so that sentence really is true only for non-vertical lines. So we have to point out that vertical lines are parallel to other vertical lines. Okay? And then this second sentence about the perpendicular lines and opposite reciprocals. Well, don't we know that a vertical line is perpendicular to a horizontal line? All right? Vertical line straight up and down, horizontal line straight across. They're perpendicular to each other. But it's not technically correct to say that their slopes are opposite reciprocals. Because the slope of the horizontal line is 0, but what's the slope of the vertical line? Undefined. There's no such thing as the reciprocal of undefined. Okay? So we have to point out these two exceptions dealing with vertical lines. But they're fairly simple to remember. I mean, what else would you expect a vertical line to be parallel to? Right? And what else would you expect a vertical line to be perpendicular to besides a horizontal line? So the things that you would have figured out on your own, but I needed to point those out to you. All right, so how are we going to use slope to identify and distinguish between parallel and perpendicular lines? If we find the slope of two lines and the slopes are equal, we have a pair of parallel lines. If we find the slopes of two lines and the slopes are opposite reciprocals, then we have a pair of perpendicular lines. If, however, one of the lines has a slope that's undefined, then we got to go to here, right? If both slopes are undefined, then both lines are vertical. That means they're parallel to each other. If one slope is undefined and the other slope is 0, that means we have a vertical line and a horizontal line. They're perpendicular to each other. Make sense? Okay. What if we find the slopes of two lines and those slopes are not equal to each other and they're not opposite reciprocals? Then what would you conclude about your two lines? Would you conclude they're parallel? Nope, their slopes aren't equal. Would you conclude they're perpendicular? Nope, their slopes aren't opposite reciprocals. So you would conclude that those two lines are neither parallel nor perpendicular. With me? All right. Now here's the way the book says it. See why I paraphrased it and made new definitions? They say what I said. Hopefully I said it a little more straightforward. Slopes of parallel lines. Two non-vertical lines have the same slope if and only if they are parallel. All vertical lines are parallel. Slopes of perpendicular lines. Two non-vertical lines are perpendicular if and only if the product of their slopes is -1. Hey, I didn't say that. I said opposite reciprocals. But look, what is the product of a pair of opposite reciprocals? So they just say it a different way than I said it. And their way's fine. I mean, their way's the way the books always say it, okay? That the product of the slopes equals -1, all right? So vertical and horizontal lines are perpendicular. So what the book says what I said. I hope my way makes sense to you, and I hope the book's way makes sense to you. Questions? All right, let's do a few more examples. Skip number 4. Let's do number 5. The directions say, determine whether line WX and line YZ are parallel, perpendicular, or neither. Graph each line to verify your answer. Graphing each line is fine. That doesn't really verify our answer, though, because when you graph these, are your graphs going to be perfect? No. So even if they're supposed to be parallel, your graph may not look like they're exactly parallel. So graphing a line I'm fine with. Saying that verifies your answer, I'm not real happy with that. I'm not really sure you can verify your answer through a graph. Okay? Because the way we're doing it with the slope formula is a better way than looking at the graph. All right, so number 5. Let's find the slope of line WX. So look at the notation I'm using. The little m for slope, and then line WX. So that means slope of line WX equals. All right, now, I'm just using these 2 points. I'm ignoring the other 2. Y2, what's Y2? I'm going to use the 5. You can do the 4 if you want, but I'm going to use the 5. Minus Y1, 4, over X2, 4 minus X1. All right, so 5 minus 4 is 1, 4 minus 2 is 2, and that's the slope of line WX. Now, let's find the slope of line YZ. So slope of line YZ, see the notation, equals Y2, -7, minus over 8 minus 4. -7 minus 1 is -8. 8 minus 4 is, and I reduce that and get -2. Or it might be better if I think of that as a -2 over 1. You don't have to. You don't have to write it as -2 over 1. All right. Are these slopes equal? No. So the lines are not parallel. Are these slopes opposite reciprocals? Yes. So the lines are perpendicular. You see what to do? All right. Do number 6. Let's hold off on the graph. We'll do that in a minute, okay? Go ahead and do number 6. Do you get the slopes I got? Are these lines parallel? No, the slopes aren't equal. Are these lines perpendicular? No, these slopes are not opposite reciprocals. So what are these lines? Neither. All right, and since I forgot to graph the number 5, let's graph. Just make your own little coordinate plane. And this is why the graph's not a good verification. We're just going to sketch the graph. We're not going to try to be very precise at all. So W has coordinates 2, 4. 1, 2, 1, 2, 3, 4. Be about there for W. X is 4, 5. 3, 4. X is about there. So, and that's all. We're not going to find x-intercepts and y-intercepts. We're not going to find intercepts. We're just going to plot the 2 points and draw the graph. Okay? All right, then for YZ, let's see, 4, 1. That's Y. 8, negative 7. And it looks like, yeah, maybe they are perpendicular. I can't prove it from the graph, but so that's all you got to do on the graph, okay? Am I right in thinking that the graphing is something you're fully equipped to handle? Okay. I'll let you do your own graph for 6 then. All right, let's keep going with these. Let's try 7. Find the slope of WX. All right, for the slope of WX, well, you go ahead. Y'all do it. Do number 7. $190. Anybody get what I got for 7? And try to learn how to spell the word parallel. There's only 1 R, but there's 3 L's. So try to get that right. Because I see a lot of 2 R's, then not enough L's. So spell parallel. Do 8. Anybody get what I got for number 8? Okay. Questions? You've done all this before? Have you done the problems like these where you have to find the slope of both and see if they're parallel or perpendicular? Excellent. All right. Number 9, and I'm not going to cheat and use a coordinate plane like I'd planned. Graph the line that satisfies each condition. We need it to pass through the point A with coordinates 3, -4, and it needs to be parallel to line BC with points B with 2, 4, and C, 5, 6. All right, if it's parallel to line BC, it has the same slope as line BC. So if we find the slope of line BC, we will have found the slope of the line we're supposed to graph. So let's find the slope of line BC. Slope of line BC equals 6 minus 4 over 5 minus 2. So that'll be 2/3. So that means the slope of any line we want that's parallel to line BC must have a slope of 2/3. Okay, so let's make our graph. Ooh, that's not even close. First, let's graph the point 3, -4. 1, 2, 3, 1, 2, 3, 4. So A goes about right here. And then here's how we use slope. I always go over to the right and then either up or down. Technically, you can go to the left and then either up or down, but I just always go to the right. I always go over to the right, whatever the denominator is, and then if the slope is positive, I go up the numerator. If the slope is negative, I move down whatever the numerator is. I always do it the same way. That way I never confuse myself. So if you like going to the left, fine. Just don't confuse yourself because you might confuse me. So the slope is 2/3. So the run is 3. 1, 2, 3. And the rise is 2. 1, 2. And that's where another point on our line goes. So we're going through the point A like the directions tell us to. We have a slope of 2/3. That's the line they want us to graph. Seem reasonable? All right, let's do number 10. All right, the slope equals 3, and it passes through the point -1, 4. All right, well, they've told us everything we need to know, haven't they? So we don't have to find anything. Maybe we need to think of this. When the slope is 3, what's the denominator of 3? It's 1. So the A is -1, 4. So -1, 1, 2, 3, 4. So A goes there. Now, if the slope is 3, which is the same thing as 3 over 1, I can go 1 to the right, and then 3 up, 1 to the right, 1, 2, 3 up. And that's the line they want us to graph. All I expect you to do on these graphs is to sketch it, just like I am. Okay? We're not going to try to, I mean, if you want to get your straight edge out and all that, I'm not saying you can't. I'm just saying all I require you to do is sketch it. All right? Number 11, passes through the point with coordinates 7, 3, and it's perpendicular to line LM, and then they give us the coordinates of L and M. What do we know about the slopes of perpendicular lines? Opposite reciprocal. So let's find the slope of line LM. That would be 5 minus -3 over -1 minus -2. 5 minus -3 is 8. -1 plus 2 is 1. So that's the slope of line LM. That's not the slope of the line we want. The slope we want The slope, how would I say that? Slope, I'm really tempted to say slope we want, but I don't want to. Slope that we're going to use is going to be what? Negative 1 over a. And now we're in business. So we make our coordinate plane. P is 7, 3. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3. So P goes about right there. Then negative 1/8. I'm going to go 8 to the right. 1, 2, 3, 4, 5, 6, 7, 8. And then 1 up. 1 down, right? Because the slope's negative. There you go. And I know what some of you are thinking. At least I think I do. Wouldn't it have been easier to go to the left? Yeah, probably it'd fit on the plane better. And if you want to, you can. Left and then up instead of right and then down. You think you got it? I think you got it. So here's what I want you to work on. Page 190, 1 through 3, 5 through 11. Those shouldn't take you very long. 13 through 25 odd, 29 through 39 odd, 53, 58 through 65, 72 through 74. Woo!